Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of December 4th, 2023 this time around. And we have been in recent weeks. You've been following the story of Venus tracking from Leo into Virgo in the morning sky. And then we've been watching the moon pass by bright stars and planets and making some interesting pairings. And this is great because the moon's been bright and obstructing our view of other things. But we're going to continue that for a little bit this week, even though the moon is fading away and it's dark enough that we can see some other objects in the sky. We want to look at the moon here a little bit because it has some really close, interesting pairings. And I think some of these things that I'm looking at as close pairings, depending on when you're looking and where you are in the world, you might actually be able to see an occultation of the moon passing over the top of some of these things. And as a guide, remember, we say that the handle that we look at the Big Dipper that looks like this, and we say the handle of the Big Dipper arcs to the bright star Arcturus. And then we spin on down to Spica. We keep going in that same direction to Spica. And Spica is the bright star at the base of the Y of Virgo, the wine glass shape of Virgo that looks like that. Spica is the brightest star right there. We've looked at these stars in recent weeks because of planets, Venus, passing through the area. But remember, this is in the morning sky. So right now, this region of the upper part of Virgo rises, depends a little bit on your local time on where you are, but rises sometime around 1 o'clock in the morning. So at 1 o'clock in the morning, you can start to see this region. And on the morning of the 6th, any time after 1 o'clock, the moon will pass very near Zavijiva. And Zavijiva is that star right here, the second star up. So Porrima is at the base of the cup of Virgo, and you go up 2 on the right side, and you got Zavijiva right there. The moon's going to be right there. The moon's going to be 35 or 40% full. So we got a little bit over a third full moon. So a nice moon and a nice pairing with Zavijiva. Now, by 1 day later, you just go out on the 7th, and the moon will have moved down here to Porrima. And Porrima is a brighter star, 2.7 magnitude, 3.6 for Zavijiva. So with this 2.7 magnitude star, the moon will now only be about 30% full, a little bit less than a third full. It will be very close to Porrima. By the next morning, every morning, just bam, bam, bam. So you miss a morning, you're going to have something interesting to see the next morning. So every morning, by the next morning on the 8th, the moon will be down here by the bright star Spica. And Spica is a big, bright star, first magnitude star. That's the star, if you will, of this constellation, of this group. And the moon will be about 20% full and right next to Spica. One morning later, on the morning of the 9th, the moon is all the way down to 12 or 13% full. And it is a beautiful, beautiful crescent moon then. And it sits just below Venus. And Venus is the biggest, brightest object in the morning sky. But by the time it slipped past Virgo, the upper part of Virgo, this part of the asterism of Virgo, it probably doesn't rise until about 4:30 in the morning. So anytime after 4:30 until it gets light, you'll be able to go out and see Venus and the moon, a nice, beautiful crescent moon. Of all of these things, every single one of these is worth watching. It's worth going out and seeing every single one of these things in the morning sky. This is the don't miss one. If you can get out on the morning of the 9th and see Venus and the moon there together, that would be fantastic. Now, in the evening sky, if you're not out in the morning observing this, and you want to look at stuff in the evening sky, as it gets dark, Jupiter is getting closer and closer, higher and higher in the sky as it gets dark each night. And so Jupiter is probably still a little bit east of due south, but it's close to due south. The big bright object in Aldebaran is up. As it gets dark, Aldebaran translates from Arabic as eye of the bull. The is owl. So it's the eye of the bull here, and it's in the V of the Hyades. Excuse me. In the V of the Hyades, Aldebaran is this big bright orange star right here. Aldebaran is about 33 degrees east of Jupiter, and maybe a little south, but 33 degrees east of Jupiter. That's sort of 3 fist widths at arm's length between Aldebaran and Jupiter. So go out, practice finding the bright star Aldebaran in the V of the Hyades. Enjoy the V of the Hyades. Enjoy the view of Taurus this time of year. Find Jupiter right there. You got a small telescope. Go ahead and take a look at Jupiter and spend a little bit of time enjoying Jupiter's moons and see if you can watch the moons moving around here. But then make a right angle here, so that it's like a right triangle, and move up in the sky about 21 or 22 degrees. Probably 22 degrees is closer. So about 22 degrees, about 2/3 the distance from Aldebaran to Jupiter. Scan slowly up this direction, and I do it with binoculars. Big light gathering binoculars if you've got them, 50 millimeter lenses or something like that. And you scan upward and scan upward and scan upward, and you're going to come across M33, the Triangulum galaxy, the galaxy in Triangulum. And it's a big, beautiful face-on spiral galaxy. I have seen it. You've probably heard me talk about this before. I have seen it with my naked eye in the mountains under dark skies. And so it is possible to see this. It's a big diffuse object. It doesn't have a lot of sky brightness. That is to say, because it's face on this way, you're looking through the thin part of the galaxy, the galactic disk right there. It doesn't have a huge brightness difference between the sky background and the galaxy, so you need dark skies to do this. But it also helps to use binoculars and not the telescope, because this telescope spreads the light out too much and makes it just kind of into the background, and you lose sight of it. But it's also something you can try to use your averted vision. Use the rods on the side of your eye to look up that direction and see if you can see that fuzzy patch right there. But a good pair of binoculars are going to help you out a lot here. So that's our dark sky object for the week, is a galaxy in Triangulum. It's a big, beautiful nearby galaxy, part of the local group, and we've got this face on, so it's big but faint on the sky, low sky brightness on the sky. See if you can find that in the evenings, and then pick one or all of these mornings to go out and see the moon making pairings with other objects. And I hope you have a good week of observing ahead, everybody. And as always, thankful. I got one more thing for you. One more thing. I'm going to close it down, but I got one more thing. The 9th, right there, on the AM of the 9th, that evening on the 9th, that's our earliest sunset. And that's our earliest sunset because of our coupled orbit and rotation. We move, every rotation of the Earth, we've moved a little bit in our orbit, so we have to over-rotate to get the sun back directly overhead. And even though we won't have our latest sunrise for quite a while here, what happens is sunrise, because we're closer to the sun right now, this time of year, we're closer to the sun than other times of the year. We're going to get closest approach is going to be in January, early January coming up here. And because we're so close, we're moving faster in our orbit than average, which means we move further. We have to rotate more than average to get the sun back directly overhead, or to rise or to set. So sunrise and sunset come a little bit later than you would expect them to come if we were moving at a constant speed in orbit around the sun. So that is to say, here's the sun, and here we are pointing at the sun. By the time we've moved in our orbit, we have to over-rotate a little bit to get the sun back directly overhead. And so that extra rotation takes about 4 minutes. So there's a 4 minutes difference between what we call the sidereal day, the day measured by the stars, and the solar day to get the sun back overhead. But it's not exactly 4 minutes, and it's more than 4 minutes if we move further in our orbit than average, and it's less than 4 minutes if we move less in our orbit than average. So that more in our orbit that we're moving right now causes us to have to rotate more, and it causes then sunrise and sunset to come a little bit later than we would expect otherwise. And so sunset has reached its latest point here already right now, and it's going to start getting earlier. So you can celebrate that. That's midwinter sunset time. So that was one thing I hadn't even thought to talk to you about that this weekend. And I thought, well, as we're closing it up, let's give that a shot. So hope you have a great week, everybody. Thanks for watching, and we'll have something new for you next week.